This video is to go over lesson 304, homework 3A. Number 5, write an algorithm for dissecting a parallelogram into a triangle. Write the set of steps, in other words, to make a parallelogram into a triangle. Number 6, justify each steps you used in dissection of the parallelogram into a triangle. So problem number 5 and 6 are kind of related. If you write the set of steps, that's problem number 5. Number 6, you write the set of, you justify each steps. So how does the y two segment matches, and how do you know that's a straight line? Things like that. Number 7, write an algorithm for dissecting a triangle into isosceles triangle, but not the equilateral triangle, and rearranging it into a scalene triangle. How do you do that? Write the set of steps. And number 8, justify each steps. So it's similar to number 5 and 6. Number 9, suppose that Jane has an algorithm for dissecting a trapezoid into a rectangle. Explain how you could use Jane's step to dissect a rectangle into a trapezoid. So the backwards. Can you just simply do that in a reverse order, or do we have to do something else? That's number 9. Number 10, use your algorithms to dissect a trapezoid into a rectangle and dissecting a rectangle into a non-rectangular parallelogram. Describe an algorithm for dissecting a trapezoid into a non-rectangular trapezoid. So that's number 10. So first you started out with any trapezoid, not the isosceles one again. Careful. Change it to, how do we change it to rectangle? Once we change the rectangle, we want that to be no rectangular parallelogram. So what's the step from trapezoid to rectangle? What would be the set of steps to make the rectangle to non-rectangular parallelogram? That's number 10. Number 11, use your algorithms for dissecting trapezoid into a rectangle and dissecting a triangle into a rectangle. Describe an algorithms for dissecting a trapezoid into a triangle. So number 11, we know how to make trapezoid into rectangle, and we know how to make triangle into rectangle. Okay, so how can we make triangle out of trapezoid? Maybe we can make rectangle, and then once we get the rectangle, reverse the process of making a rectangle from a triangle. So reverse the process so that we can go from trapezoid to rectangle and rectangle to triangle. Number 12, the diagram suggests Noriko's method for cutting a trapezoid into a triangle. What point on segment CD does she need to find so that CF matches with DF? That's 12. And we have trapezoid ABCD, and then we have something like this, and the intersection is F. And we also said that's C prime. So the question is, what point on segment CD does she need to take so that CF will be congruent to FD? We can't really take the random point on CD in order for CF to be matched with FD. So what kind of point is F? What kind of point F is? B, will the edge from B to B prime, which is right there, B prime, be straight? So how do we know this line is straight? We went over that in class. Why? How do we know this B to B prime is straight line? There's no. How do we know? And also, how do we know A plus AB, which is the bottom base of triangle, is straight line? How do we know that? Okay, so that's the end.